All right, let's do this. So we're on week 5. And I was sending some emails basically telling you to keep up because there's like 6-7 hours worth of work every week, and if you haven't done any programming, you're gonna be in trouble. So yeah, we're in week 5, and if you haven't done most of these other weeks, you're already like close to 30 hours behind. So now we're starting with week 5. Week 5, we're going to talk about repetition again. Nothing new really, just reviewing it. So for that, I am going to look at the notes that I have for the other class that I did on Monday. Not that. Why not? Why not show you this too? So just a little quick something that has nothing to do with, well, I guess it has a little bit something to do. This is how you convert positive and negative numbers into signed hexadecimal. Okay, so the rule is basically you get the number. So you have the number negative 15 and you try to convert that thing into a negative hex, into a signed hex. Okay, so first of all, these are your bits, right? There's 8 bits. The first one is 1, then 2, 4, 8, 16, 32, whatever, right? So 15 is basically, if this is 16, then 15 is going to be the sum of all these previous ones, which is basically the same as saying these are all ones. Right? So that's the 8 plus 4 plus 2 plus 1. That's a 15 decimal. Okay? So you convert the thing into decimal, into the binary equivalent of a decimal number, ignoring the sign. You're going to keep in mind the sign. So this is the original binary. Right? These first ones are all zeros. These ones are all ones. Then what you do is you get ones complement of the original. And what that means is you just basically flip all the bits. All the zeros turn into ones, all the ones turn into zeros. And that's your ones complement. Then you add 1 to that whole thing, and that's your twos complement. And then basically this is F1. So F1 is the sign hex. This is how you represent a negative number. And the reason we do this is because you want to be able to do both addition and subtraction by just adding binary numbers. It reduces the complexity of things. Okay, just so you know, when you start taking the assembly class, or one of you is taking the assembly class right now, so that's your little review. You're welcome, Rigo. Okay, no problem. So, next one is just the review piece. All right, so the one thing that I did not mention, and I'm just going off of let me zoom in on a little bit on this. So the one thing that I didn't mention last time, maybe, actually, let me see how far I got it with you. So the previous week, on Thursday, this is what we talked about. And let me look at it real quick. Okay. So I showed you how to validate input, which is you get the user to enter some kind of an information, you check to see if the information is good. In this particular case, we're checking to see if a number is less than 0 or bigger than 123. And how the issue with this is that if you have a single if, it will happen one time. So if they enter a bad H, here, you catch it with the if, you tell them no, that's a bad one, ask for another one, but if they enter another bad one here, then the if is not going to repeat, it's just going to stop, and we're going to go to the next thing, whatever that is after the if, and the program may possibly break. So what you do is you basically just replace this if with a while, and now what's going to happen is the user is going to be stuck in this loop forever until they get to enter the correct age, which is between 0 and 123. Anything less than 0 or bigger than 123 is not going to work. Okay? I showed you the format for a for loop, right? How you basically have a start, you have some kind of a stop value, right? The stop value is this, and then you have some kind of a step, right? So in this particular case, I'm telling it, start the variable number at 1, go on while number is less than or equal to 10, and an increase number by +1 every time. Okay, another way to do this is I can also say, I can say, so number is equal to number plus 1. I can say number plus equals 1. And I can also say number plus plus. Right? So those are the different ways. These first two, we already know from Python. If you took Python, this last one is unique for C and C++, and Java, I guess it's not so unique, right? So the plus plus is the shorthand, but to do plus 1, okay? How you can rewrite, so again, if you have a for loop, if you want to use a for loop, you should know where it starts, where it stops, at what number it starts, at what number it's supposed to stop, or I guess how many times it happens, okay, and by how much it increments. If you don't know these things, you could use a while loop. You can rewrite any for loop using a while loop, right? So this is your for loop right here, and here I am rewriting the for loop using a while loop, right? So this is your start, this is where it stops, and this is your increment or your step, okay? Some other loops here, some examples that it doesn't have to start at 1, right? It can start at 5. You can also start it at 0, and you can have it increase by not plus 1 but by plus 2 if you want to. You can make it go backwards, right? You can start at 10. You can tell it to go on while the number is greater than or equal to 0, and then go backwards, minus 1, minus 2, whatever number you want. You can have nested loops. You can have one loop inside of another loop. That works too. You can have a loop that happens as many times as the user wants to. It's basically all you got to do is just replace this number here with some variable that the user decides. You can do the same thing with a while loop. You can have a never-ending loop that goes on while until the user enters a certain value, right? So this loop goes on forever. That's what the true is for, until the user enters a -999, and at which point we stop the loop. Okay. As soon as you hit the break, that is where the loop exits. So if you entered a -999, you will not see this message, right? The loop will stop right here at line 111 and exit. It will never continue down and see any of these other lines in the loop, if there are any. Okay. What is this here? Talked about the different kinds of variables. This is your, I guess, first time for you to learn about the scope of variables. And what is the scope of a variable? The scope of a variable is where it can be used, where it can be changed, where it can be seen, right? Basically, wherever you declared a variable, that's where you can use it. In this particular case, I declared the variable a inside of these curly brackets, right? Which means that I can only use a in there. If I try to use the a right here, I'm going to get a compile error, right? As soon as I try to use it, as soon as I try to use this, it will tell you something like, right here, top one, right? Where's the error? Use of undeclared identifier a. Okay, well, I have declared it, but I have declared it inside of my curly brackets, which is why I cannot use it anywhere outside of these curly brackets. Similarly to how if I have a loop, and I have some kind of a variable declared inside of this loop, and if I try to do this kind of a stuff, and I try to compile the thing, you're going to see that there you go, line 139, right? Line 139, we have an issue. What is the issue? Undeclared identifier a. And it's the same thing. I declared it inside of the curly brackets. I cannot use it outside of the curly brackets. Okay, that's so. What is the scope of this variable a? The while loop, right? When I say what's the scope, you gotta know what I mean, okay? So you need to know these different error messages, because a lot of times they will help you, figure out what's wrong with the code. The error messages in C++ are not the most user-friendly, but whatever, okay, you can learn them. In here, I had an example where I was showing you how to show these different numbers. And the numbers that I'm showing were 1, 2, 3, 4, 5, 6, right? That's why this thing starts at 1, goes to less than or equal to 6, in increments of 1. And the purpose of this was to show the commas for the first well, everything except the last one, and then as soon as I get to the last one, I'm not going to show a comma, I'm just going to show a new line. Right? So it's just a different way to format the thing. And then I had some hints for your assignments. This was like the currency conversion or whatever, you had the weights and kilos. How you can format it using this notation. This is your C++ notation telling it we're going to reserve a certain number of spaces for this number that we're inserting there. So we're inserting the yen, which is some kind of a value. And we're telling the program reserve 4 spaces for this value every time you show it. Okay, so this is the C++ notation, and I personally prefer the C notation. Okay, so C is the older language upon which the C++ language is based. C++ is backward compatible with C, so as long as you include some of these libraries like the stdioh, that allows you to gain access to everything that's available, or some of the things that are available in the C language, such as this printf, right? And the printf, if you become familiar with this, you will realize that this actually exists across most languages, right? So it's in Python. If you took Python, there was a print, and there was like a % thing in there that also works the same. If you go to Java, Java also has a printf. If you're using C, that also has a printf. I think even the default shell in Unix has a printf too. Okay, so it's all over the place. The next thing was showing a bunch of characters, right? But certain number of characters per line. For this, we use the Ascii chart in the assignment. I showed you what the Ascii chart is. It's a table that shows you that so this is 21, so let's just look at it 21 real quick. 21. All right, so 21 talked about, create all these different, create this. You're going to put 10 characters per line, and these characters, we're going to generate them using the Ascii table. So the Ascii table is the numerical representation for every character on your keyboard, right? The exclamation, the quotes, the uppercase, the lowercase, the actual numbers, they all have numerical representation. So for example, uppercase A is 65, right? Uppercase A is 65, uppercase Z is 90, right? So that is how I went in there and I said, okay, I'm going to generate a bunch of letters. How this number 97, if I cast it, if I say char 97, that will turn into the letter A, lowercase a, because that's the ASCII for lowercase a. So then I said, okay, well, I'm going to show you the letters from 97 to 108, which is letters A through L, and I'm going to do it 4 per line, right? So I start a loop that starts at 97, goes on until 108, increases by +1 every time. I showed you 1 character at a time. I counted every character, and I put them all on the same line, right? If I counted 4 characters, then I insert a new line, and then I restart counting, okay? And how to count odds and evens, right? So you have some kind of an input, right? And it could be a random number, and you're checking to see if that number is 0, you stop. And if the number modulus 2 is equal to 0, then that's an even. Remember that if you have any kind of a number modulus 2, the only possible things that you can get are going to be either 1 or 0 or 1, right? So if I had modulus 3 here, right, those numbers are going to be 0, 1, 2. Okay, so the modulus actually allows you to kind of reduce a bigger number into a smaller groups of numbers. And the bottom line is that if any number is evenly divisible by 2, then the remainder is going to be 0, and that happens to be an even number. Okay? So that's what we did last time. This time, we're just practicing with these things. So we have week 5. Did we do min, max, and sum and average and all that stuff? No, I didn't show you that. Okay. No. Okay, so what I'm going to do is I am going to wipe all this stuff out. because that's what we did last time, and give you a fresh one. And by the way, in case you're wondering, I'm using Sublime. All right, Sublime Text Editor. It's compatible on all operating systems, and if you set it up, it will allow you to compile things in it. So if you're on a Mac, you do the command B, and that compiles right here on the bottom. All right, or you can just get this whole thing, copy it, and put it in CLine, which is what
another plugin too that'll
let you run.
compile and then execute it.
Well, you can execute this here too. I can execute this
Well,
one.
it won't run inside though.
It will. Cout hello. The problem is, right? So it will run, but if I have an input, if I have like a CN, then it will start messing up. So it will basically, it will run the whole program, but if you have any kind of an input, it will not take the input the way it should. So if you tell me what the plugin for that is, I'll you know.
I don't know, I Googled it.
Okay. So, all right. So what I'm going to do here is, let me erase all this stuff. Just give you some hints for today's assignments, and that'll be it pretty much. And let me make sure that I got this stuff here. Alright. Follow my own protocol. Alright. This is my lecture 928. Okay, and this is practice with repetition. Practice with repetition, accumulation, min, max, sum. Okay, so I guess let's talk about finding the min and the max and all that good stuff, because I may have not mentioned it last time. So let's say I want the user to enter, I don't know, X numbers, and I want to find the smallest, the average, I guess sum, that good stuff. Okay? I guess maybe I can also count how many certain numbers were entered, but let's not do that for now. Okay, so first I'm going to have an int x, right? I'm going to ask the user how many numbers, and let the user enter that thing. Okay, that doesn't change anything for you, does it? Not for you. Okay. Okay, so cn x, and then I'm going to have a loop for int I is equal to 0, I is less than x, I plus plus, and then in here I'll tell the user to enter some numbers. Let's say num. Okay, so num, cout, enter a number, and I'm assuming it's going to be an integer. Let's say integer, an integer cn num. Okay, and then what I'm going to do is, I guess let's look for the sum. This is your example of accumulation. So I'm going to start the sum equal to 0, and then every number that was entered is going to be added to the sum. Sum is equal to its old value plus the number that was entered. All right, so let's say the user enters 1, 2, 3, these are the numbers that they're going to enter, right? They want to enter 3 numbers, right? If they enter 3 numbers, what are the values of I? I is going to be equal to 0, 1, 2, right? And then I can say even which number they're going to enter. Enter integer I there, right? So let's see how it works. Save it and run this thing. Alright, so how many numbers do I want? I want 3 numbers. Right? Enter integer 0, right? That's because the I is 0 here, right? Let's go with 1, integer 1, now the I is 1, right? 2, integer 2, now it's a 3, right? And the loop stops. So these are the numbers that it generates, but I want to change how this thing shows up. right? So this thing here, instead of 0, 1, 2, let's say I want to change it so it shows me 1, 2, 3, right? I'm going to go in there, I'm going to add a +1 on this, and then when I run my program again, I want 3 numbers. That's my 1, that's my 2, that's my 3. So it starts at 1. Okay? So these are the numbers that I'm going to be entering. So the first time I go through the loop, right, this thing is equal to, it's going to be equal to sum is equal to its old value. So we're talking about this one. Whoops. All right. So I'm talking about this one. So the first time sum is equal to 0 plus 1. Okay. So that's the first time I go through the loop. Then I go the second time through the loop. The user enters the 2. All right. So now I'm at this one. Okay, so now the sum is equal to its old value plus 1. The old value was 1, right? So this was 1 from before. So now it's going to be equal to 1 plus the new value, which is 2. So it's 3 now. Then I'm going to go again through the loop for the third time. I'm going to enter the 3, and sum is going to be equal to its old value, which is 3, plus the new one, which is this 3, and now sum is equal to 6. Right? And that's your example of accumulation. Okay? And it helps if you actually, write out what you expect from this and how it should work, and then kind of try to trace the different steps and maybe as comments. Okay? So that is how you find the sum of things. If I wanted to do an average, I do cout average is equal to my sum divided by however many things I had. Right? That's my average. And other thing, let's say I want to, now let's do the smallest. Okay, so the algorithm to find the smallest is as follows. So I'm going to put a multi-line here. Okay, algorithm to find smallest with a T. Okay, so it goes like this. 1, make a variable smallest equal to the first number entered. Okay, 2, compare if any other number after the first is smaller. Okay, and I guess 2b, if the above is true, or if any other number is smaller, that is your new smallest. Okay, and in other words, what I'm doing is, let's say I have 4 numbers, 4, 3, 2, 1, right? So initially, what I'm going to do is I'm going to say smallest is equal to 4. Okay, and then I'm going to check to see if any other number is smaller than my smallest. So if 3 is less than smallest, right, I'm going to say the smallest is equal to 3, right? So now at that point, I have moved I started smallest as 4, I compared it to this is smaller, so now smallest is equal to 3. So I basically moved it, now it's a 3. Okay? Then I go and I say, okay, well now let's compare this to the next number over. So now if 2 is less than my smallest, then smallest is equal to that 2. Right? So I'm comparing this to the previous smallest, which was the 3, so now it's a 2. Okay, and let's say this last one is not a 1, but it's a 10. Question?
And you have to run this through the whole code.
Well, I'll show. Yeah, this is basically, these are just like the separate steps to just so you can see what happens, and then we're going to do this with the loop.
All right.
So then the next thing is, so now the smallest was 2, right? So I compared it. So initially, basically, smallest is equal to 4, right? Then I compare smallest to 3. Is 3 less than smallest? Yeah. So now smallest is equal to 3. Then I compare 2 to smallest, which was 3. Is 2 less than 3? Yes, it is. So now smallest is equal to 2. Then I'm going to compare it again, one more time. So if my 10 is less than smallest, it isn't, right? Not true. Then smallest stays still at 2. Okay, so we go through a list of these numbers and we pick out the smallest one and we make this variable equal to it. Okay, so now that we know how this is going to work for a small set of numbers, let me make a variable smallest. Okay, and now the question is, how am I going to make smallest equal to the first number? Okay, and how do we know which num is the first one entered? What tells us? Alright, so I'm going to go through this loop. I'm going to ask the user to enter however many numbers they want. They can enter 3, they can enter 300, 3,000, whatever, right? How do I know it's, through, as they're entering numbers, how do I know it was the first number that they entered? I, right? So look at the I. I starts at 0, and it's going to go on and on and on until it reaches one less than the number they wanted to enter. So if they wanted to enter 3 numbers, I is going to be 0, 1, 2. If they wanted to enter 5 numbers, then it's going to be 0, 1, 2, 3, 4. Okay? But let's go with the 3 numbers, right? I is equal to 0 the first time we go through the loop, right? So I equals 0 the first time we go through the loop. Right? So if I say if my I is equal to 0, then smallest is equal to that number. This basically makes smallest equal to the first number. Make sense? Okay. So now that we have made it equal to the first number, now we got to go and tell it, compare if any other number after the first is smaller. So this is true for the first time we go through the loop. True the first time we go through the loop. Okay, so if I go in there and I say else, this is going to happen every time after the first time we go through the loop. Okay, so I go and put an else, throw the curly brackets, and then I do another if. Right? And now what we're going to do is we're going to compare if any other after the first is smaller. Okay? So just like we did with this here. Okay? I'm going to say if any of these other numbers is less than my smallest, then smallest is equal to that number. And that's it. Question?
Instead of having that whole first if statement, can't you just put smallest equals 0? And then run if after that in the while statement?
That is interesting question. So let's say, all right. So the question is this.
Set it global.
Instead of making this equal to the first number that was entered, what would happen if I set it equal to 0? So let's try this. Let's imagine. So imagine the user is going to enter 10, 20, 30. Right? This thing is 0. Right? It's not equal to the first thing because we said we're not going to do that, right? So let's say I'm going to say num equals 0 initially. Yes? So
no,
we're
smallest.
Sorry. Smallest is equal to 0. Okay? So if smallest is equal to 0, then we're going to still do the same thing, right? You're going to say, all right, well, if any number is less than smallest. Okay. Is 10 less than 0? Nope. Is 20 less than 0? Nope. Is 30 less than 0? Nope. So what happened with smallest? It stays as zeros. As a 0. Right? That's how it would affect the smallest. Right? And by the way, so you can't find the smallest that way. And you can do similar thing with like the largest, right? The largest is basically going to be similar thing. Say largest, right? Largest is the same business. So you basically have a variable, largest is equal to the first number, just is equal to that first number. And then if any other number If any other number is greater than largest, then that is your new largest. Okay, now let's say largest was equal to 0. Okay, so if largest is equal to 0, and we're not doing this, right? We're not doing this. We're only doing this piece here. Okay, so now let's imagine the user enters a -10, -20, -30, and largest is equal to 0, right? Okay, you go in there and you say, okay, largest is 0. Is 0 bigger than -10? It is. Then you go into the next one. All right, so is negative, my bad. So -10 is num. Largest is 0. So is -10 bigger than 0? No. So largest is still 0. Then we go to the next one, right? -20, that's your num. Is -20 bigger than 0? Nope. So largest is, we're not going to do this. Largest is still 0. Then we go to the next one. The user enters a num, -30. Is -30 bigger than 0? Nope. Largest is still 0. Okay? So if you make them equal to 0, right, it's not going to work. If they enter everything positive, it's not going to work for the smallest. If they enter everything negative, it's not going to work for the largest. And that's why you want to have it, set it equal to that first number. Okay? There's other ways to do it. You can, there's a certain fixed, there's a way it's built into the language where you can tell it, okay, make smallest equal to the smallest number possible in the C++ language. You could do that. And then make not smallest. So the way I would work around this is I would make smallest equal to the largest possible number in C++, so that any number that they enter will be smaller than that initially, and then I can capture the smallest. And with the largest, I would start with some really, really big number, like the biggest possible number, negative. And then so that any number that they enter is going to be bigger than that, so that I can get, I can make this thing equal to some other number. Okay? But that's kind of cheating, Why am I going to resort to trying to look up what's the biggest and the smallest when I can just, think about this and, come up with a solution myself. Okay? So that's the idea. That's the algorithm for finding smallest and largest. And maybe you don't believe it. So let's see if it works. Cout smallest equals smallest and cout largest equals largest and okay, so I run this thing. I want to do 3 numbers. I'm going to do 1, 2, 3. Smallest is 1, largest is 3. And whenever you have these kind of things, test it multiple times. You can start with simple numbers. You don't have to go with like, I'm going to enter 15 numbers to test this. No, go with 3. Alright, so I tested 1, 2, 3, then test 3, 2, 1. Still gets it. Alright, run it again. Now this time test it for 3 numbers, but then put the 1 in the middle. Alright, is it still going to find the smallest? Yup, found it. Now test it one more time. Put the 1, put the 3 in the middle. Whoops, wrong. Run it again. 3 numbers. Alright, I'm going to put 1, 3 in the middle, and then 2 at the end. And if it catches them, if it manages to find the smallest and the largest in every possible arrangement of these numbers, then it works fine. Any questions? Still awake? All right. So let's go to the class webpage. All right. So what I'm going to do is I'm going to just go through this and just give you some hints on these assignments, and then that'll be it. So, 26. Alright, so 26 is write a number guessing game. The computer will generate a random number between 0 and 100. The user will be prompted to guess the number. If the number guessed is greater than the random number, an appropriate message will appear with a similar message for a low guess, and the user should keep guessing until the correct number is guessed. And you should tell the user, I guess that's it. Oh no, how many times it took them to guess. Alright, So first of all, if I was thinking of a number between 0 to 100, what would be your first guess? 50, right? And I tell you, okay, no, it's smaller than that. What will be your next guess? 25. You want to go between 0 to 50, divide that thing in half, right? And I tell you, okay, no, it's higher than that. So then the next step is go between 25 and 50, divide by 2. What's that? Right? And then you just keep dividing it in halves and halves and halves. And at most, you will take 7 guesses to figure out a number. As long as these, as long as we're talking about sorted numbers from 0 to 100, and they're all, not repeaters. And then this is different from just randomly guessing something. By the way, this is called a binary search. Okay? So the binary search is we split it in halves every time. And this is different than just randomly guessing a number, right? So if I was just randomly guessing a number, the worst case scenario would be I'm starting to guess them like, okay, is it 1? No. Is it 2? No. Is it 3? No. Is it 4? No. It's 99. It's 99. So at the worst case scenario, I can guess up to 99 times if I don't use the binary search. And on average, if I play that game millions and millions of times, it will average to about 50 guesses. Just if I was just to randomly guess things, statistically speaking. Okay. So that's the purpose of this exercise, is kind of to teach you about this binary search. So it will go like this. So just a quick review about how to make random numbers. So what I'm going to do is I'm going to comment this piece out so I don't see it again. I don't like entering things into my own programs. Okay, I'm lazy. So good programmers are lazy. The lazier you are, the more efficient you're going to figure out how to do the code. So maybe. So next thing is making these random number things, right? And let's see if you remember the random number business. And for a random number, I have to include time h, right? I think I also need to include stdlib.h. So this was for the time function, right? We're going to use time function. We're going to use rand and srand functions. Okay, so unlike Python and in some other programming languages, C++ is a little bit of a pain to make a random number, right? So first thing you have to do is something like int iseed is equal to time null. So this is just to get the system time, right? And if you want to see what that looks like, iseed equals iseed and l. It's just going to be some huge number. There it is, right? Some huge number, and if I run the program again, that number is going to change by a little bit. It's just going to keep increasing, 67, 68, 70. So it basically, I guess it's the seconds counted from some time in the past, right? I don't know what number this is, 3, 6, that's a billion, right? So anyway, we're going to get this huge number. And then the next thing that I'm going to do is I'm going to plug this big number, because this number here is not very random, right? It's just a number that just keeps increasing and increasing and increasing and increasing, but it's not really random. The next thing I'm going to do is I'm going to plug in this ever-changing number into my srand function. Okay? And once I do that, right, you already know what the iseed looks like. I'll take it out. Then let's have a look at cout rand mod equals rand and l. Right? So if I run this thing now, you're going to see that now this thing makes me some kind of a random number. Right? So there's this number. If I run it again, different number. They're kind of the same, which is kind of annoying. All right? Not much of a change. Well, they're actually kind of changing a little bit. Right? They're not as predictably the same as that other number. Okay? It still starts with an 8, 8, whatever, but then the rest of them right? The rest of these digits are kind of changing quite a bit. Okay? And that's what we're going to take advantage of. So the next step to do is we're going to grab this rand. So rand makes me a random number, which is one of these, right? It's still not a super random number, but whatever. We'll deal with what we have. So then I'm going to say, okay, int random num is equal to rand, and then modulus, let's say 3. Okay? So I don't know if you remember this, but if I have any number and I say modulus 2, what is this going to be equal to, possibly? It could be 0, it could be 1, right? So if I have something else, if I have any num and I say modulus 3, that thing is going to be either equal to 0, 1, or 2. Okay? So that's how the modulus operator works. Okay? If you have, let's do one more, in case you didn't get it. Any num modulus 4 is equal to 0, 1, 2, 3. Right? So basically what I'm saying is, if I get any of these random huge numbers and I apply the modulus 3 to them, then I'm going to get either a 0, 1, or 2, which is going to be sort of a random number. Okay, so question?
So if I enter modulus 4, for example,
yep,
I can only get random numbers that are 1, 2, and 3, or 0, 1, 2, 3.
So if I, 0, 1, 2, 3. So let's change this to 4. Correct. If I do modulus 4, I should only get random numbers that are 0, 1, 2, 3. Right? It might, just to piss you off, generate the same random number a bunch of times, just to make you think that maybe it's not working. But it really is working. So let's do this. Random num equals random num and del, and then I'm going to run this program a bunch of times. So there's a 3, 2, 1, 0. Oh wow, how nice. 3, 2, 1, 0. Oh, you suck. 0, 0, 3, 2, 1, 2, 2. There you go. All right. Question?
So is the rand function actually necessary then if you're only going to 3 numbers? Can't you just do the time?
The time? Well, yeah, but the idea is that the time will always kind of predictably change by +1 every time, versus the rand does not change as predictably as the time. So basically what rand does is it gets, srand generates a list of random numbers. So this thing basically, if I give this thing, let's say srand 0, then what happens is we're going to have some random numbers like this and this and this, right? But it's going to be, and from this list of random numbers is what happens when I call this. So as soon as I call my rand function the first time, right? If I have, let's say, this is my random number 1, and random number 2 is equal to rand modulus 4 or whatever. Okay, let's even get rid of the modulus. Right? Let's just do it like that. Okay, so if I have just this situation, all right, and I'll show you. So let me get this. You're going to see that there are the same random numbers over and over again. So random number 2, random number 2. So what happens is, because I am giving this the same value, this will generate the same list of pseudo-random numbers every time. And what this does is, this pulls from that list of numbers. So the first time I call the rand function, that's going to pull this number. The second time I call the rand function, that's going to pull this number. Okay, so if I run this, you're going to see 2 random numbers, right? I wasn't even close, but whatever. And then if I run it again, they're the same numbers. The reason they're the same numbers is because, again, this thing generates the same list of pseudo-random numbers from which this pulls. Okay, so that's why I need to go in there and I need to pull the system time, feed that thing in there, and now my list of numbers is going to change every time. All right, now these are going to be different. So if I run it, different, well, slightly different. That first one will stay the same a bunch of times, but whatever. Right, they're different. And now when I apply the modulus to this, I do modulus 3, or let's go with 4, modulus 4, then we're now further reducing these giant numbers into groups of 3, whatever that is. So we're kind of adding extra randomization in there. Okay? So there you go, there you go, there you go, there you go, there you go. Right? So pseudo-random. Okay? So these are not real random numbers because somebody went in there and wrote a certain algorithm for what kind of a list of numbers srand needs to generate. And if you really want to have true random number generators, you would need to have like some kind of a really random natural event, like looking at subatomic particles bouncing off each other and stuff like that, right? Those are true random number generators. Okay. And there's some really interesting experiments in there. If you want to look at it, there was a study done by Princeton University. It's called the Global Consciousness Project.
Oh, yeah.
Have you heard of that one? So it's basically you have a bunch of random number generators, truly random number generators, based on these subatomic particles bouncing off each other and stuff, in different places in the world, right? And what they have discovered was that if you have some kind of catastrophic events that allow mass people to tune in, like 9/11, right? A lot of people are like, oh, this happened. Or something else, like some crazy event happens around the world where maybe millions of people tune in at the same time. The act of these people tuning in affected these random number generators. Yeah, so you can go Google it and look at it. But yeah, we're apparently we're affecting the randomness of the universe by tuning in.
Is that srand? It's accessing a list.
Yeah, no, srand generates the list.
It generates the list.
Generates
but
a list.
Values of those lists are there's a set number.
So for every certain value that I give this thing, it will always generate the same list of pseudo-random numbers.
How many numbers are in a list?
I'm not sure.
Tons.
Yeah, lots of numbers. Good question. I'm not sure.
Can you access different parts of that list then?
Yeah, every time. So let's say you have this thing is going to make this number, then another number, then another number. The way you access parts of this list is by just calling this function. So when I call it the first time, it will go in order. So the first time I call it will get this number. The second time I call this function, it will get this number. If I had another one after that, then it will go for this number. And then there's a bunch of other ones after that, and we'll just access them in order. But these numbers, these numbers are going to stay the same for a certain fixed value here, which is why I want to change this value so that this generates me a random list of random numbers, and then I can further reduce these by using the modulus operator. Anyway, so let's say this one here is, let's say this is 5 and this is 10. So if I do rand modulus 5, this is a random number between 0 to 4, right? And the one underneath it is a random number between 0 to what? 9. Okay, you got it. Now, let's say I want to make a random number. Want to make a random number between, let me change this to 6, all right? 6, so now this is 0 to 5. And I'm going to change this to 11, so now it's 0 to 10, right? Make it nice and easier. Okay, so I want to make a random number between 10 to 5. How do I do that? So let's say I want to do int random num3 is equal to rand modulus what? How do I make a random number from 10 to 5? Oh, sorry, 10 to 5. 10 to 15, that's what I meant. 10 to 15. Okay, good guess. So if I say 16, what is this going to do? This is a random number between what?
1 and 0 and 15.
That is from 0 to 15. Okay, but I want it from 10 to 15. Huh?
I was thinking an if statement. You can enter.
You could do that kind of stuff.
Literally, yeah, like you just add something 10.
Add something 10. Okay, good. So what if I do this? What if I tell it, okay, well I'm going to have this number to begin with. All right? So I'm going to say 10 plus. And then I'm going to add something to this so that I can make a random number from 10 to 15. So what do I need to add to 10 to make a random number between 10 to 15?
Modulo 5.
6.
4, 6.
All right? So this is my 10. This piece here makes me a random number from 0 to 5. Right?
Yeah.
And if I add a random number from 0 to 5 to 10, now I get a random number from 10 to 15. Make sense? So basically, you add this first digit, goes at the front, plus, and then this number is this minus this plus 1. Right? So if you wanted to generalize it, you can say int min is equal to 10, max is equal to 15, and then random num3, well, let's do another one, int random num4 is equal to min plus rand, then modulus max minus min plus 1. There you go. Alright, not very hard. They could have easily built this into the C++ language so that you can make random numbers easier. Like the way you would do it in Python is just say, okay, well, I have a random number and that thing is equal to randint from like 10 to 15. But no, you gotta pull the system time and you gotta feed it into the srand, and then you gotta have to do the rand, and you have to do the modulus, and then you have to add and subtract things. Welcome to C++. Okay? So things are not as easy as some other languages. But that's okay. It teaches you some fundamental things that you need to learn, such as the modulus. Okay? Alright, so this is how we make a random number, and the purpose of this thing was basically we're going to make a random number from 0 to 100. So this is your P26 hint, right? So I'm going to say, alright, random num is equal to, how do I make a number from 0 to 100? Rand modulus what? 101. Right? That's my random number. And then I can do something like guess is equal to, well, let's just leave it like that. I'll say while true. It's a loop that goes on forever. And I'm going to have some kind of a maybe int guess. Okay? And then if I'm going to ask the user cout guess the number. And then it might be nicer for you to just show yourself the number first. Alright? Cheat. So show yourself the random number is equal to whatever value it is. Okay, and then guess the number. They enter their guess, and if their guess is equal to my random number, then I break the thing. Okay, and if they don't, then I just keep going and looping and looping and looping. So what you might want to do is you want to count, right, how many guesses it took them. Count plus plus. That's it. Okay? Don't look at the hints unless you absolutely get stuck on these, okay? Otherwise, you're not going to learn how to solve these on your own, which is the skill you're trying to get here, right? Oh, so, and then if their guess is less than the random number, then maybe you want to give them some kind of a message. Cout, no, it's higher than that. Alright? And you can also tell them what range of values they should guess if you want to, make it a little fancier. Right? Give them the range, right? Initially tell them, okay, guess a number between 0 to 50. Then the next time, instead of telling them, no, it's higher than that, tell them, okay, guess a number between 50 to 100. Alright? So change the ranges if you want to get more practice. So that's that. Next one is, that's 26, 27. I already showed you how to find smallest, largest sum average with random numbers. So I guess this was your hint for this. Okay. P27 hint. Sure, see ya. The next one is 28. Alright, you have a gymnastics score, you have a bunch of judges, and you're trying to write this program. Okay, 4 judges, they're supposed to enter a score between 0 to 10. How would you do this with the least amount of code is the question. Okay, so P28. I will take this out. Okay, so this is your P28 hint. So all you need is really one judge. You need the score, the total. Maybe you need the judge number, and that should be good enough. All right, and you know that this thing is going to be for 4 judges, and I can say 4 judge num is equal to 1, while the judge number is less than or equal to 4, and judge number plus plus. I go in there and I ask the user see out. Let's do a do while. No. See out. I'll tell them judge num. Enter score. Right? And cn. Instead of judge, call it score. Alright, score. Okay, and then what I'm going to do is, let's see how that works. So if I run this thing, judge 1 enter score 1, 2, 3, right, 4. Okay, it works. It works if I do good scores, right? But if I run this thing again, I give it okay. The scores are supposed to be between 0 to 10, -1. Now it goes to the second judge. I don't want to do that, right? So I got to go in there, and how am I going to change my judge number? I'm going to go in there. I'm going to say, okay, well, if my score is less than 0 or my score is greater than 10, then I'm going to reduce my judge number by 1. Okay? So the effect of this is going to be I go a negative, I go a really big number, right? It basically stays at judge 1. Okay? And otherwise, if the score is good, I can just say, all right, well, my total is equal to total plus score. Okay? That's your 28 hint. Next one, 29. Is practicing with the arithmetic skills. Alright, so it goes like this. You ask the user if they want to add, subtract, or multiply. You generate 2 random numbers. If the user gets it wrong, you repeat the question again with the same numbers until they get it right. Okay, once they get it right, you ask them if they want to do this again. If they want to do it again, then you offer them the choice of what to do between adding, subtracting, or multiplying. 2 new numbers. If they get it wrong, you repeat the question. If they still get it wrong, you repeat the same question until they get it right. And then once they get it right, you again ask if they want to play the game again. If they don't want to, program stops. Okay? So, this is your P29 hint. P29 hint. Alright, so let's say we're going to have int num1, num2, right? Num1 is going to be equal to my rand from, if I want to make a random number from 0 to 9, help me out. What do I do? 10. Okay, that's my first number. Num2 is equal to rand 10, right? These are my 2 random numbers. I'm going to ask the user what they want to do. So let's say I'm going to have like something called op. Maybe I'm going to have another one called answer. There you go. Okay, so I'm going to say op, cout, would you like to add, let's say that's going to be 1, subtract 2, multiply 3, right? Those are the choices. And no new line needed. Cn, that's going to be my op. If my operation is equal to 1, this is my addition, right? Then what am I going to do? I'm going to ask the user cout what is num1 plus num2, and then I'm going to get the user to enter their answer. Okay? And while their answer is not equal to the correct thing, I'm going to keep repeating these questions. So I'm going to basically go and grab this thing, get this, put it right in there. All right, I'm going to say something like incorrect, and repeat the same question over and over and over and over until they get it right. Okay?
Real quick, the
Yep.
while is the constant loop, right?
That's a loop that will go on forever until they get it right.
Oh.
Right? So while their answer is not equal to the sum of the two numbers, repeat the question with the same two numbers and then loop forever until they get it right. Okay? Now once they get it right, I'm going to do it all the way after the if. Right? I'm going to say cout, correct, and then would you like to play again? Okay? And then maybe I want to say yes is 1, and then no is 2. Or else no is 0. Okay? So if they don't want to do this, come on. Alright, so let's say I'm going to maybe have another variable, call it repeat. Okay? And then as soon as we get to this, I say cn repeat. And then if my repeat is not equal to 1, right? If they don't want to repeat, then break the thing. And it's going to tell you, well, wait, break what? I don't have anything to break because you have a break that's outside of my loop. Okay, I'm going to add a loop where I need it, which is right here, right before I generate my two random numbers. All right, so that's the first one. First curly bracket, second curly bracket. There you go. Okay, that's pretty much it. So what you got to do is you got to do the other ones. So do the subtraction and multiplication in here. Very similar to this. Yeah? Okay. That's 29, 30, penny to doubles, or $1 million. Okay. So you're offered the choice of $1 million today or a penny, which is going to be doubling its value for the next 30 days, every day. Right? So on day 1, it's 1. On day 2 is 2. On day 3 is 4. Then it's 8. Then it's 16. And what would you choose? You would go with the million? Last, what's that?
I heard everything until the last part.
So, all right. The question again is, I offer you a choice. I give you $1 million today, or I tell you, okay, I have this magic penny, which is going to double its value every day for 30 days. Would you like the penny at day 30 or the $1 million today? Why is that?
Because let's do the math behind it and we find out.
Okay, all right. So what you're going to do is, that's the purpose of this one. So what we're going to do is, let me just take this out, because I don't want to enter things in it. All right, so this is your P30 hint. P30 hint. Okay, so all you got to do is basically set up a loop for int day is equal to 1 while day is less than or equal to 30, and have some kind of a variable double penny. Penny is equal to 0.01, the actual dollar value of the penny, and then make the days increase by +1. And what you got to do here is make the penny double its value, right? And show the penny's value every day. right? You know how to do that?
Yeah.
All right, penny is equal to penny times 2, also known as penny is equal to penny plus penny. Either way works, right? That's how you double it. And then look at the value. Show yourself the value of the penny every day. So I'll show day 1, this is the penny. Day 2, this is the penny. And you're going to see what it is. And the answer is it's like $5 million something at day 30, which is crazy. Okay? So that's why you should have a savings account and one of those S&P 500 index funds, so that your money doubles up every. So the statistics is every year the S&P 500 increases by 10% average, and this has been true for the last 100 and something years, including the Great Depression, including the Great Recessions, and all these other economic turmoils that we have experienced. All you got to do is put the money in the S&P 500 and then just forget about it. Just don't look at it. Don't worry that it's going to crash at some point, but then eventually it will go up. As long as the country America exists and it's working, the S&P 500 will average 100 per year. 10% per year, which is in 10 years you double your money, which is an interesting exercise, right? If you have a savings account and you put like $20,000 in it and you just leave it for a while, or if you just keep adding to that savings account, what happens to it? All right, so that's an interesting little game to play. Okay, so let's have a look at P31, which is the dice game. And in it, you're going to generate 2 random numbers between 1 and 6 to simulate dice. So you're going to create one random number, another random number, and those are each dice, which is supposed to be between 1 to 6, a number between 1 to 6. And after generating these 2 random numbers, you're going to show the total to the user, and then you're going to ask the user if they want to keep those. If they don't want to keep those 2 numbers, then you're going to generate 2 new random numbers and show the total to the user and ask the user if they still want to keep them. If they don't want to keep them, then you generate 2 random numbers. Again, you show the total. If the user wants to keep these, then you are going to generate 2 more random numbers for the computer. And then what you have to do is you're going to compare these 2 random numbers and the total for those against the ones that you rolled, and then determine who wins. In this particular case, the computer rolled a 9 and you rolled a 2, so you lost. And that's basically how the game is going to work. Your hint for this is as follows. You're going to need a couple of variables, maybe some kind of a variable to decide whether they want to keep these. You make 2 random numbers. The random numbers are going to be between 0 to 6, so 0 to 7, or actually it's going to be from 1 to 6, so 1 plus 5. Okay, and then what we have to do is we have to do the same thing. 1 plus a random number of 5 will give you a random number between 1 to 6, right? This is random number between 1 to 6. And when you roll it, you show the users these 2, and you ask them if they want to keep them. If they say yes, they want to keep these, then you break the loop, and then after that you're going to just make 2 more random numbers for the computer, and you compare the total of these 2 against the total of the next 2 after them. So this is your hint for P31. And now let's have a look at P32. So P32 asks you to write a program which asks the user to type in the length of 3 sides for a triangle ABC and determine if this thing is a right triangle. These are 3 possible criteria that a triangle can be a right triangle. And then also check to see if the triangle is equilateral, which means that all sides have to be equal. A is equal to B and B is equal to C. Okay, and then you're going to have to do a couple of test runs. And if it is not either of these types of triangles, nothing should show up. Okay, but if it is a right triangle, you show it's a right triangle. If it's equilateral, you show it's an equilateral. So it will go something like this. You're going to need a couple of new variables, right? These are your 3 sides. You're going to ask the user to enter each of these sides like so. You have to do it for the rest of them as well. And then you're going to see if if one side squared is equal to the sum of the other 2 sides squared, then that is a right triangle. And you're going to do a couple of more else ifs for the other 2 cases, which are these 2 after this. And then your final case is to check to see if a triangle is equilateral triangle. And the way you check to see if it's an equilateral triangle is if all the sides are equal, which means that if one side is equal to the other side and the second side is equal to the third side, then this must be a equilateral triangle. Okay, so this is your hint for P32, and your hint for P33. First of all, P33 was similar to the one where we had to show 10 characters per line, except in this one we have to show 1,000 numbers, as many of them per line as the user determines. The user is going to enter the number of numbers per line to be shown, and that value is supposed to be between 10 to 30. So if they enter this value, which is less than 10 or bigger than 30, you're supposed to validate the user input and make sure that they enter a value that is only between 10 to 30. And the way that we're going to do this is we're going to have some kind of a variable which is going to count our numbers that are being shown. We're going to determine the numbers of per line, which is going to be entered by the user. Make sure you validate the user input using a while loop so that they can only enter between 10 to 30, a number per line of 10 to 30. Then you make a loop that goes on from 1 to 1,000. You're going to show your numbers. Each of these numbers is going to be shown on the same line, and you're going to count every number that is being shown. And if you have counted as many numbers as the variable num per line, which is what the user has entered, then you're going to show a new line, and then you're going to restart counting. And the end result is going to be something like the one that you see here. If they enter 12, you're going to put 12 per line. The purpose of this %4i is so that we can space these numbers evenly, reserving 4 digits for each of these, and it will be nicely lined up. Okay, so if I run this program, it will look something like this, right? They're all neatly lined up. And that's your last hint. If you have any questions, please send me your emails. Come see me during the office hours, and I will help you out. And that's all I have for today. See you next time.